In this lecture, we will cover viewing and monitoring processes. Viewing and monitoring processes. An operational system can have hundreds or thousands of running processes. We can view and monitor these processes using various native tools, such as PS or the top command. The PS command shows basic process information in 4 columns. PID, also known as PID, it's the process ID number. TTY is the terminal the process belongs to. Time is the cumulative time CPU has given to this process. CMD is name of the command or program being executed, in this case bash. Commonly used options with PS command include -A to show all, -E for every, -F for full format, uppercase F for extra full format, -L for long format. When you run PS-EAF command, this is the following result that you will see on your screen. For example, UID is the user ID or process owner's name. PID is the process ID number. PPID is the process ID of the parent process. C is the process utilization for the process. S time is the process start date or time. TTY is the terminal the process belongs to. Time is the aggregated execution time for the process. CMD is the name of command or program being executed. Again, in this case is bash. Information of each running process is maintained and kept in the /proc file system. The top command. Another popular tool for viewing process info is the top command. It displays the statistics in real time and helps to identify performance issues on the system. When you run the top command, this is what you see on your screen. For example, PID, user, that's the name of the effective user who owns the process. PR is for priority. NICE is the NICE value that sets the priority. VIRT, that stands for virtual memory size. RES is resident memory size. SHR is the shared memory size. S is the process status. The process can be in different status. For example, if you see a uppercase R, that means the process is running. If you see an S, that means the process is sleeping. %CPU is the share of CPU time used by the process since last update. %mem is share of physical memory used. Time plus is the total CPU time used by the task in hundredths of a second. Command is the command name or command line. In this case, we're running top, and that's what it's showing.
So let's go ahead and try the PS command so you have an understanding of what it does. So I'm going to just run PS. Now let's break it down to see what it is showing us. So the above output shows basic information in 4 different columns. So these are the 4 different columns which are listed here when you run the PS command. So the first one is PID, which stands for process ID number. So that's the ID number assigned to any particular process. TTY is a terminal that process belongs to. Time is the time CPU has given to this process. So CPU usually assigns certain amount of time for different processes depending on the priority. And this is where you can see that. And the last one is CMD. Call it command or name of command or program which is being executed right now. And that's what it's showing. For example, if you see we have bash, we have cat, we have PS command which we're currently running, and it's showing us what command is running. This is the basic information which you find in 4 columns when you run just the PS command. In a real environment, usually you need more information. So there's many options which you can use with the PS command, and some of those are listed here. For example, -A equals to all, so all processes. -E is every. -F is full format. So -F is extra full format. -L is long format. So you can practice these with the PS command and see what they do and learn and try to get more information from it regarding your processes. Let's look at some of the examples. Let's look at an example with PS -eaf command. E is for every, A is for all, and F is for full format. So let's run that command, see what it shows us. So ps-eaf. As you can see, there's a whole lot of information. Let's go up to the top so you can see what it does when it's run. So at this point, we're running this command and it's showing us all this information right here. And this is just a lab environment. If you're in a real environment on a regular server, you will probably see a lot more information than this. But this information gives you the breakdown of it. Let's start from the first column, UID. It tells you the user ID or process owner's name. So which user is running this process? So for example, most of these processes are currently being run from root user. So if you see, I have highlighted root here. If it was a different user running a different program or a different command, you can see that here. This helps you break down when you're troubleshooting on exactly who's running what, and if there's a particular program which is taking up a whole lot of CPU usage or causing a lot of problems, you can tell which user is running it, and you can go to the user and see what's going on and try to troubleshoot from there and solve that problem. And the next one is PID. PID stands for process ID number. So each process has an ID assigned to it, and it tells you that. PPID, which is the third column, stands for process ID of the parent process. So if there's a process which has a parent process, sometimes a regular process may have child processes. So it tells you the process ID of the parent process. C, which is the next column, stands for processor utilization for that particular process. S time stands for process start date or time. So when was that process started? So if you see a process running really long time and it's just not ending and it's not a system program, you can tell from here what's going on. TTY is terminal the process belongs to. Time is aggregated execution time for the process. So how much time the process has taken. CMD, which command is running, or the name of the command or the program. So this is the basic information that you need to know when you start looking at processes, or if you are, let's say if you're a system administrator, this is key information that you can look at. You can run this command and see what's going on, and you can continue to run this command different intervals and see what's causing problems and what's going on with your system. And it's really good place to start and look at your system when troubleshooting. So let's clear the screen and we will move on to the next example. So the next one, which is the top command, it's a very useful command when they want to look at their system because it gives you the information live. So basically whatever's going on your system, it will be running top command and it will tell you exactly what's going on to your system real time. So this is another popular tool for viewing process information. It is the top command. It displays the statistics in real time, helps to identify performance issues on the system. So let's run the top command and let's see what it does. As you can see, the top command, I've run it already. Let me make the screen full screen, so you can see basically everything else that is running, because on a shorter screen or the smaller screen it only shows up to the memory point, but there's two other columns, time and command. Just keep that in mind. When you're running it, you will be looking at time and command as well. So we will break each column down and see what they do and what they're all about. So currently the top command is running. There are many fields which we will cover. For example, very important field when you first start looking at performance issues with top command. One, it's live, so it's telling you the load average. So this is really important. You start looking at the load average. Let me make the screen full again. It actually gives you three load averages. So basically load average of your system load. It's a lab environment. It's 0, 0.01, 0.05. So it's basically not doing much. The load is good. And if you were troubleshooting a system and you see averages going really, really high, that means it's something bad is going on and you want to know what's going on, and then you can further break it down. You can see how many total tasks are running. One is running, 84 are sleeping, one is stopped, right? So it gives you a lot more information about what's going on. It gives you information about your CPU percentage, how much memory is free. This is the memory field, and also swap. It tells you how much swap is being used. In our case, as you can see, when you're troubleshooting and you see your memory right now, it's showing a lot of memory free. If you don't see a lot of memory free, if you see like really low numbers, that's where you need to concentrate your troubleshooting. That's where your problem is. If you see swap, that's where you can identify the problems with your memory or swap. So these are some basic fields which you'll be looking at. Now, also to quit out of top, you can just press Q on your keyboard and it will quit out, or you can do Control C to quit out of top. Now, let's break down the important fields here, these fields I'm talking about. So let's cover them one by one. So PID stands for process ID, which we've covered already with the PS command as well. It's really important information that you would need to know. And user is the name of the effective user, owner of that process. Once you identify which process is causing problems on your system, you can go check with the user, hey, what's going on, or just kill the process if it's really causing a lot of issues, or go talk to the person. And let's say a programmer created a program which is causing issues, you can go talk to him, see what's going on, maybe change the priority and do what else you need to do. Next one is PR. PR is priority. This is also really important. If there's a program running which can be really low priority and you need to change it, this is where you'll be looking at. This is where you will check the priority of the programs, which we will cover deeper in further sections. But this is the priority. That's what PR is. Nice value. This is one really important field. Nice value is basically a value which basically means priority as well. Depending on the nice value assigned to a process, that will determine the priority of the process. And you can also manipulate nice values and change the priorities of particular programs or processes that are currently running. The next one is VIRT, which stands for virtual memory size. The next one is RES, which stands for resident memory size. SHR stands for shared memory size. The next field is S, which stands for process status. This is also really important field because it tells you, let me highlight this right here. S means process status, what status this process is in currently. And if you see this field is currently changing because we're running the top command, it's showing us live information. So if I highlight this, if you see most of these S's, that means they are basically sleeping processes. Most of these processes are the processes that started because the system started. Most of these are system processes run by root, and S means sleeping. So it could be several different states the process could be in. So for example, D is for uninterruptible sleep. R is if the program is running or the process is running. S is sleeping. Most of the system process will be sleeping until something happens and they start running, or they start to change their status into R, which is running state. T is for traced or stopped. Z is for zombie process. So let's look at, if you keep monitoring this field right here, you will see S. But in a few seconds, if you keep monitoring it, we're running the top command. Let me make the screen full. So There's one program which we're running, which is top right now, and that should also show up here. So as soon as the screen changes and the top process comes right here, as you can see, top is running. It's in R status, which means the top command is running. And basically, that's the only process that's currently running. So this is how you can tell what's going on, what the status is. Now let's move on to the next one, which is percent CPU. That's the share of CPU time used by the process since last update. If you see right now, most of these system processes are running on 0 CPU time, but if you're troubleshooting and you see some process taking 90% CPU or 70% CPU, that will be a place you would need to look at. The next one is percent mem. That's the share of physical memory used. Next one, which is not showing here, let me make the full screen again. It's this one, time, and the last column is command. So let's look at that. Time is the total CPU time used by the task in hundredths of a second. Important field. And the last one is command, the command name or command line, name plus options. So once you figure out if it's running, how much CPU it's using, and then you can look at what command is running or what program is causing that. So two fields will be really important once you realize which one is causing CPU issues or memory issues, is look at the command name, what command is running, what's causing this, or also the user who's running that. So this will help you troubleshoot a lot more. Um, and this is a basic understanding of monitoring processes through the top command. It's very useful. It comes mostly installed. It's a native command, and you can run it on basically most of the Linux distros. And this will give you a whole lot of information, especially when you're troubleshooting and when you want to know what's going on with your system. I would advise you to get really familiar with top command with PS and look at it, try to run different programs and see what happens, what changes. This will help you a lot if you're thinking of having a career in Linux. I hope you learned something useful in this video as well, and I will see you in the next one.